to Music and Technology, the science of sound. Today we're going to be talking about microphones and cables. As always, you can find this presentation in terms of its slides on our Google Classroom. And don't forget, at the end of watching this video, head back to our Google Classroom and answer this week's discussion question. All right, let's begin. So in this section, we're going to take a look at the signal flow of a typical kind of home studio setup. And particularly, we're looking at connecting a microphone and recording it in your computer. And the signal flow works like this. We're going to have a sound, which we've already talked about in our last lesson. That sound then gets to the microphone, which is an input transducer, and that's going to convert the sound pressure variations into voltage variations, or what we would call an audio signal that goes along a wire. And microphones generally connect with an XLR cable, which we'll look at in detail coming up here. That cable is going to be connected to your audio interface. Now, an audio interface actually is a collection of many different components, and the first one is that the microphone is going to come into contact with is called the preamp within your audio interface. The preamp will amplify the signal up to the standard operating level. Once you've configured that, then it enters the analog to digital converter, which is another essential part of the audio interface. That digital signal, which is a stream of ones and zeros at this point, continues on to your computer and into your DAW, or digital audio workstation. Once in the DAW, it can be the sound, the sound is then manipulated in a variety of ways and is mixed with all the other tracks. To end the signal flow, the sound is sent from the DAW, so from your computer, back to the audio interface, which is then converted from digital to analog, and then it heads to your output transducer, which would be your speaker. So remember, input transducer is the microphone, output transducer is the speaker. So here's just a summary of the how everything is connected, the flow of the signal. So it goes from the sound to the microphone, which converts the sound pressure in the air to an audio signal. The audio signal travels down the XLR cable to the audio interface, which has a mic preamp built into it, as well as an analog digital converter that transfers that signal from a USB cable into your computer and DAW system. The output goes back from your computer to the audio interface, which then the signal is converted from digital to analog, and to your speaker, which is your output transducer. So, microphones as transducers. A microphone is a transducer. Now, a transducer in general converts from one energy type to another and tries to do that without changing the signal at all. And a microphone is converting between sound pressure variations in the air into voltage variations in a wire, which we would call an audio signal. Now, though we try to make this change as kind of transparent as possible, to have as little variation from the sound pressure variations to the voltage variations, there is always going to be some change that happens. The microphone itself is going to color that signal in some way. So not all microphones are the same. There's many variations and specifications, and that really reflects on how that signal is changed and how it is transduced. Now, we're going to be comparing two microphones, the Shure SM58 as well as the AKG 414. And we're going to be talking about them as dynamic and condenser microphones, as well as taking a look at their polar patterns and their frequency response. So now we're moving into microphone types. There are many different types of microphone. The first choice you're going to have to make when purchasing or choosing a microphone is going to be the microphone type. And though there are many types of microphones, the main two we end up using are going to be condenser microphones and dynamic microphones. And they function in very different way, and they have kind of different needs. So let's talk about them in different ways. First, we're going to start to talk about the dynamic microphone. Typically, on stage, we find a dynamic microphone, and in the photo here, we have the Shure SM58. Now, at school, we have a whole set of these microphones. They are perfect for on-stage performances. And the SM58 is a standard kind of handheld stage microphone. And it's very good for on stage because it doesn't pick up outside of its small area very well. It's designed to be on stage in a loud environment where there are monitors with a lot of volume from the microphone itself. There's other instruments also on stage, and it doesn't want to pick up, and it's very good at that. So it's excellent for that situation. It's also very rugged. If it gets dropped or swung around, the sound engineer or the teacher doesn't have to worry that we're going to break the microphone and have to replace them. We have had to replace a couple, but they are very, very rugged and durable. The other really important thing to note is that dynamic microphones do not need any external power. Absolutely no power at all. All you have to do is plug in the cord and cable, the XLR cable, and boom, you're golden. The other type of microphone is a condenser microphone, and it tends to be used in the studio. Because condenser mics are so sensitive, we have to be careful using them on stage in a live situation. If you think about a singer on stage, she's singing into this microphone and she needs to hear herself. So there are the monitor speakers right in front of her, and she's hearing the signal from that microphone. If that microphone is very sensitive, it'll actually pick up the sound from the monitor and cause feedback as that sound goes through the microphone, through the PA, back out of the monitor and back into the microphone. So we don't want that. That's a terrible sound. So in a live stage situation, we tend to use a dynamic microphone which won't pick up from that area, or is much less sensitive and won't get that chance of feedback. Now, there are certain situations on stage where you do want to use a condenser microphone, maybe above the drums. And we're just careful not to route that signal back to the monitors. As well, really important is that condenser microphones require some form of phantom power. It's usually 48 volts, and there's usually a button that is found on your audio interface that you can push that has plus 48 to turn on the power of this microphone. And in fact, the microphone I'm using right now to record this video is a condenser microphone that requires 48 volts. It's actually the Scarlett Studio microphone. It's pretty good, I think. All right, let's talk about microphone frequency response. So microphones are designed to work in a wide variety of situations and for a wide variety of applications. Some are designed, like the SM58, which is our dynamic microphone, to work primarily for vocals. And they'll be designed to produce vocal frequencies well and to reject the frequencies that are not usually part of the vocal range. A microphone like the AKG 414 or the Scarlett Studio that I'm using, the condenser microphone, they are designed to pick up everything as transparently or accurately as possible. So it's going to pick up everything. And this kind of microphone is designed to make it work within a specific situation. And it's something that we have to be very careful with when choosing a microphone for a specific application. Let's take a look at the frequency response charts of these microphones. So here we have the frequency response chart of the Shure SM58. Remember, the Shure SM58 is a dynamic microphone. We have lots of them at school. These are your typical stage vocal microphones. We can see with the SM58, if we look at the frequency response curve, it has a peak of around 5,000 Hertz, which helps the voice come through well. And the bottom end kind of rolls off, kind of the areas that would be below the voice in typical situations. So as you can see in the end here, it just rolls off. So we have our peak at about 5,000 Hertz here. Okay, boom, and then it rolls off. Okay, for those lower end frequencies. We don't want those frequencies. But if we take a look at the microphone frequency response chart of the AKG414, it is designed to pick up everything as accurately as possible. And it has a considerably flat frequency response, and we can see this in our chart here. Right, there is no real peak. It just kind of flats off, and it does drop off on the lower end, but not very quickly and at a very high frequency. And so it picks up lots of sounds in the different frequency ranges. We might consider it to be more of a transparent mic in that it picks up everything equally. So all frequencies, relatively speaking, with a couple of higher frequencies that don't pick up as well. But most frequencies along our chart, actually, it picks up the sound quite equally all across the frequency spectrum. Now, these charts are going to differ for different types of microphones that you use. And you might find a microphone designed for specific instruments, like that one that goes on a saxophone or one that goes on an acoustic guitar. But the main thing is that you choose a microphone that's designed specifically for your application, whether it be a dynamic or condenser mic. And choosing the one with the right frequency response is an important aspect for that too. What type of sounds do you want it to pick up? So let's talk quickly about microphone polar patterns. Polar, so if you think of these polar patterns like the world, okay, so we've got the North Pole of the world. You have to think of this as the top or the pole, okay, or the front end of our microphone, okay? Polar patterns describe what area the microphone picks up well and what area around the microphone that it projects, that it doesn't pick up well, that you don't want it to pick up. So let's look at the Shure SM58 again. So in this diagram here, we see the microphone polar pattern of the Shure SM58, which, if you'll remember, is a dynamic microphone. Now, it's designed, again, to be used on stage for a vocalist, and we talked about the idea of having the monitor right in front of you, right? It's very loud, and it sends out the signal that this microphone is capturing. So this microphone is designed to be held in your hand, right? To pick up well from one side of the microphone, okay? Right? One side of the microphone and not from the back end of the microphone. It's designed to pick up sound from the front and not the back of the microphone itself. And so when we take a look at the polar pattern for the Shure SM58, you can see that it is picking sound up from the front, okay, at 0 degrees up here. Okay, this is the front of the microphone. 180 is the bottom end of the microphone. And it picks up sound mostly in the front. And we call this cardioid polar pattern or directional polar pattern, where sound can only be picked up from one certain direction. And it looks very much like a heart. Okay, the cardioid pattern is a heart. So remember, dynamic microphones, sound is only coming from one side, not from all around. Okay, just like a vocal microphone. You don't want it picking up sound from behind you or in front of you. If you have the monitor in front of you, okay, if your monitor's in front of you and you're here singing into the microphone, da-dee-dee-da, you don't want the sound coming out of the monitor to come back into the microphone. So it's hitting from the bottom of the microphone itself. And that's why when we see here, the directional pattern, the polar pattern, the cardioid pattern, okay, is only from the front of the microphone. Now, if we take a look at the AKG 141, okay, or the Scarlett Studio condenser microphone, we call this omnidirectional. So if you take a look again, right, we have directional or cardioid and omnidirectional. So coming from all angles, right? There is no true polar pattern designated here. But if you look closely, this thick black line all around is considered our polar pattern, right? So if we look at the, Shure SM58, the polar pattern is the shape of the heart, this thick black line. If we look at the polar pattern of the AKG 141, it's omnidirectional, all directions. And that thick black line, the polar pattern, is everywhere. And so those microphones are designed to pick up sound from everywhere, no matter where you're standing. Now, there are all different types of microphones and different types of polar patterns. Here are just a few. Right, we have figure 8 polar patterns. We have hyperpolar patterns and super cardioid polar patterns. Okay, and so some sound gets tracked up from behind the microphone here, an equal sound from front and back here, but not from the sides. Okay, but if we look again at our AKG 141, we have the pattern. The sound is coming into the microphone from all directions. Okay, this is the direction where the sound is coming from. The microphone polar pattern. Very important to know when setting up your microphones. So microphone placement, super important stuff. Okay, I know it's really obvious, but placing your microphones and in a specific spot is really important. So we've talked a lot about different specifications of microphones, but really the most important thing when recording is where you place the microphone. How you move it around, the source that you're trying to capture, and really that's an entire course on itself. We can talk so much about that, but we're going to leave it very general, okay? And I know it's going to sound really stupid and very simple, but I kid you not, it's the most important thing here. Remember that your microphones are your ears in the studio. So place them where the sound sounds the best. And I know that seems funny, but really, the best way to place our microphone is to walk around and listen. Get your ears close and see where that thing, or see what that thing, or where that thing really sounds the best. Where does the microphone really sound the best? Use your ears first. And so, if you have someone playing guitar, move around them, get close, put your ear up to the guitar, and really start noticing how, as you move around the sound of the instrument, how the sound actually changes. If you get your ear close to the sound hole of the guitar, it's going to sound different than if your ear is next to the frets. So if you put the microphone in the sound hole, it's going to sound different. It's going to pick up the sound differently as if it were near the frets. And just understanding how the sound changes is going to really tell you where you should place the microphone. Now, when placing a mic, there are some things about the mic that you do want to know. First off, some mics are front address, so you have to place it in the front or from the side. Okay, but a microphone like the AKG 141 or the Scarlett Studio, okay, it's picking up the sound from all over, so you have to place it in the correct spot. If you place it too close to the musician, it's going to pick up all the nuances of the musician's foot tapping and so on. So it's really important to move around, use your ears before placing the microphone, and really keep it simple, right? Where does the microphone sound best? Where does the sound sound the best? Okay? Keep it simple. And here we have an example of microphone placements, right? Microphones, there's different types of condenser and directional mics used for a drum kit. Okay? It's important to know that on the bass drum, you would use a condenser mic, or maybe perhaps, depending on the type of microphone, a dynamic microphone, but you would place it very close to the sound hole, the opening of the bass drum on a drum kit to get that full sound. You would never place your snare drum microphones, or the microphone that you would like to pick up your snare drum, okay? You would never place that way over near the large tom, the floor tom, okay? Place the microphone where the sound sounds best. Use your ears first before placing the microphone. All right, the last thing we're going to talk about are cables. Very, very exciting stuff. Okay, we're working in a studio. You're going to find that there's a huge number of cables. In our classroom, we have tons and tons of cables all over the place. We have different types of cables: 1/4-inch cables, 8-inch cables, and XLR cables. Now, cables tend to wear, okay? They get used often, and so it's really important that when purchasing cables, make sure you purchase good quality connectors and have good quality cables, because they're going to last you a long time, especially if you're playing a lot. Excuse me. The first type of cable, as you see in our background, is the 1/4-inch cable. This is your typical instrument cable, or what we call a TS cable. Now, sometimes these instrument cables have a tip and a sleeve. Okay, if it's a single conductor cable, it will only have the tip and a sleeve. If it's a double or 2 conductor cable, which we call a stereo cable, very similar to your headphones, but in 1/4-inch style, there is a tip, a shield, and a sleeve. Now, these cables are susceptible to noise, and you really want to make sure that you protect it with that. A 2-conductor cable will protect that sound a little bit more because it has that shield. It's important because, especially if you're playing an electric guitar, for example, and your instrument or TS cable, 1/4-inch cable, is hooked up into the port in the guitar, but it's moving around, if the cable, okay, if the connection, the tip of the cable is moving around in the guitar port, you're actually going to get noise and sound in your recording, okay? That's why it's really important to get 2-conductor cables with the tip, shield, and sleeve, and get good quality cables with good quality connectors. That'll last you a long time. XLR cables. Okay, XLR cables have way more balanced sound, and we use XLR cables quite a bit, especially for microphones, because we don't want to get any noise. And with XLR cables, you have a better balanced sound and no noise. They are not used for stereo signals. Excuse me. They're used for input transducers, like a microphone. And remember, with long cable runs, you will want to use XLR rather than a TS or instrument cable, because if you have really long cables and the signal has to travel far, using an instrument or TS or 1/4-inch cable, you're going to get some noise out of that cable. But if you have long runs of XLR cables, you're going to have a more balanced sound with a lot less noise. So speaking of XLR cables, they look like this. They have 3 prongs on one end. We call this the male end of it. And here we have the 3 ports, the female end. Okay, XLR cables, or we also call them TRS cables, they are way more balanced. They reject noise, and they require 2 conductors with a shield, especially the TRS cables. Now, you can use both instrument cables or TS cables or 1/4-inch cables, whatever you want to call them, You can use both the instrument cables, the TS cables, as well as XLR cables to make and create your sounds a little bit better, especially when you're recording from a microphone or if you're recording from an electric guitar, for example. With the help of a direct box, this is going to help you go from 1/4-inch TS cable to an output of an XLR and a more stable sound. So with those long chord runs, you're going to actually have this, a direct box. We have a couple of them at our school. Okay, so you'll see here, you have two inputs. You would use a 1/4-inch TS cable here on the direct box, plugging into your guitar. On the back of the direct box would be the output for an XLR cable, okay, a way more balanced sound. And so to reduce noise, to reject the noise, especially when you're recording or even in a live performance, you don't want the noise of the cable. Okay, and if you have long runs of cables, you want to use a direct box, because what will happen, or how you set it up, is you would plug in with your guitar here using a 1/4-inch instrument cable or TS cable. On the back end, okay, this would be very close to the performer, by the way. On the back end, you would have your much longer, long-run XLR cable for the output that would then travel all the way to your mixing board, which might be quite a ways away, especially if the performances are way far away and the engineers and the sound people are behind. Okay, so you may use really long runs of XLR cables in combination with a TS cable or instrument cable using a direct box to reduce any noise coming from the cables. And that's it. Thank you very much for listening to this presentation and the lesson on music and technology. Okay, as always, check our Google Classroom for the slides of this presentation. As well, don't forget to answer the discussion question for the week based on this presentation. All right, thank you very much, folks. Have a good one.